In this video, we will discuss how computers convert text messages into bit strings. For a computer to store or display text messages, an encoding must be determined. Each encoding is a set of mapping between each possible character and its number representation. A program must know the correct mapping in order to map the numbers back to the intended word. In early days, computer manufacturers invent their own mappings. Well, you can imagine how hard it was to communicate between systems from different manufacturers. Luckily, the situation is not as bad today. Standard encodings were proposed and adopted, starting from the ASCII code, which used 8-digit bit strings to represent the uppercase and lowercase letters of English alphabets, punctuation, symbols, the single digits 0 to 9, some control characters such as newline, tabs, and some symbols beyond English alphabets. Using 8 bits to represent a character, we can only represent 256 different characters. While 256 characters seems to be sufficient for covering English alphabets, it is far from enough if we need an encoding that can cover characters used in all human languages. Therefore, encoding with bigger number of digits is needed. A popular choice for encoding is called UTF-8, in which a character is represented using variable length bit strings, whose length varies among 8 bits, 16 bits, 24 bits, and 32 bits. Knowing that 8 bits make 1 byte, the UTF encoding uses either 1 byte, 2 byte, 3 byte, or 4 bytes to represent a character. Here are a few examples of characters encoding in 1 byte. 2 bytes, 3 bytes, and 4 bytes. When working with text in computers, always make sure you specify the correct encoding for your text files. I'll show you an example. Let's surf the web together. This is the Japanese Wikipedia page. You see that all contents are shown nicely in Japanese. This page is encoding using UTF-8. So if we trick the web browsers to understand incorrectly about its encoding, for example, I could just intentionally change the encoding of this page from UTF-8 to other encoding, for example, Western. You see that all the text mess up. This is because the web browser used the wrong encoding in showing the text.